All right. Now that we've figured out our parent chain and how to determine our parent chain, the next step in naming our molecule is to identify the substituents. These are all of those little branch points that are coming off of the parent chain as we see here below. To name these, we simply take the number of carbons in each one of these branch points and replace the ANE of the parent chain name with the letters YL. Okay, so let's look at our first substituent right here. Okay, there are 2 carbons I can see. A 2-carbon chain is referred to or called ethane, but as a substituent, we will refer to it as ethyl. Now, let's look at our second substituent. Here we have 3 carbons. The 3-carbon parent chain name is propane. As a substituent, we call it propyl. And then finally, our last substituent is only 1 carbon. Normally, this would be referred to as methane, and as a substituent, it becomes methyl. So one thing that I mentioned in the previous set of slides, and it's really important to keep in mind, is that when finding the longest continuous set of carbons, rings and straight chains attached to rings are treated separately. Even though technically they are all attached, for the purpose of naming, rings and straight chains can never both be in the parent chain. A ring can be either a parent chain or a substituent, depending on the number of carbons. Okay, so if the ring structure is the longest continuous chain of carbons, let's look at our first example here. I have a ring that is 6 carbons long and a straight chain coming off of it that is 3 carbons long. So my ring is the longest chain. It will then be the parent chain, and the straight chain that comes off of it will act as a substituent. So the name of this compound is cyclohexane. That's my parent chain. My substituent is a propyl, 3 carbons group. So my name becomes propyl cyclohexane. Now, on the other hand, if you have a situation where the straight chain is longer than the ring, has more carbons than the ring, as in this situation, the straight chain acts as your parent chain and the ring is a substituent. My straight chain here is 4 carbons long, so that would be butane. My substituent is a ring of 3 carbons, so it would be cyclopropyl. My name is cyclopropyl butane. Okay. Now, for substituents with complex branches, meaning essentially a branch that itself has another branch point, there's a long way to kind of get through this, okay? You have to number the longest carbon chain within the substituent. And you have to start with carbon that is attached to the parent chain. Okay, so looking at this example, I see that I've got a substituent that is a chain, but then there's 1 carbon coming off of that chain. Well, I number the longest chain of carbons I find in the substituent. Okay, in this case, it's 4, so it would be butyl. Okay, then I'm going to number my carbons starting with the 1 being the carbon that's attached to the parent chain. Okay, so here I see that this is the carbon that's attached to my parent chain over here. So that is 1, and then I number going across for the continuous longest chain of carbons. I treat my substituent on my substituent that I'm currently naming the same way I would do it if I was naming a parent chain, and this becomes a methyl group. It's in the 2 position of a butyl group. So the whole big name for this substituent is 2-methyl-butyl. Essentially what you're doing here is you're taking the rules that we're applying to naming an entire compound and you're using it to name simply the substituent, okay? Now some branch substituents have common names. okay? If you are somebody who prefers to use the common names, I will absolutely take them. Your book does use them frequently, but it involves a little bit more memorization, okay? There are two types of propyl groups. A propyl group that is just 3 carbons coming off of your parent chain is called just that, propyl. If the attachment happens at the second carbon in the propyl group, it's called an isopropyl group. Same thing with butyl, okay? You can have different attachments of this 4 carbon system to your parent chain. Sec-butyl would be when the second carbon of the butyl group is attached to the parent chain. Okay, isobutyl is when you have an isomer of butane and that is attached to the group. And the same thing with tert-butyl. It's another isomer of butane that is attached to your parent chain. Okay. You are welcome to use either system of naming for substituents. We will be practicing this heavily in class, don't worry, okay? All right, finally, carbons in the parent chain now have to be numbered. We figured out the parent chain, we figured out our substituents, now we have to actually number the parent chain to give our substituents location, okay? We number in such a way to give the substituents the lowest number possible. Okay. If one substituent is present, number the parent chain so the substituent just has the lowest number possible. Okay, here's an example. We have a 7 carbon long chain. We can number it one of 2 ways. In the first way, the methyl group is on number 2. In the second way, it's on number 6. We number so that the methyl group, the substituent, gets the lowest possible number. Now, when there are multiple substituents, you number the parent chain to give the first substituent the lowest number possible. This isn't a cumulative effect. We're just looking for the lowest number for the first substituent. Again, in our example, okay, we can number one of 2 ways. In the first way we number, our first substituent, the first group that we come across, is on the second carbon, carbon number 2. In the second way we number, the first substituent we come across, and there are 2 of them, are on carbon number 3. We're going to choose this first way of numbering because we only care about the first substituent. Now, if there is a tie, then between the first substituent, then you number the parent chain so that the second substituent gets the lowest number possible. If there is no tiebreaker, then you assign the lowest number based on the alphabet. Oh boy, okay. So we've got compounds here where you have 5 carbons and a bromine and a chlorine are attached to either end of the chain. How do I number it? It won't matter on the number of substituents. Either way, it'll be the same numbers. It'll be 1 and it'll be 5. In this situation, it is preferred that I give the 1 to the alphabetically first substituent, the bromine. Okay. Same rule applies for cycloalkanes. We number so that our substituents get the lowest number possible. Okay, now we're finally going to put the name together. Okay, to assemble the complete name, you put the number and the name of each substituent before the parent chain name in alphabetical order. All right. We are going to use prefixes such as di, tri, and occasionally we get tetra if multiple substituents are identical. So let's say your chain has 3 methyl groups. Instead of saying methyl, 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 you'll just give the 3 locant numbers where the methyl groups are and say tri-methyl. okay? We ignore the die and the try when we're alphabetizing, though. We still go just to the substituent's name for alphabetizing, okay? So again, summary of our rules. Identify the parent chain, identify and name the substituents, number the parent chain and assign a locant to each substituent, and then list the numbered substituents before the parent name in alphabetical order, okay? I want you to practice with Skill Builder 4.4, and then we're going to go through this step by step when we meet again in class.